Looks like we're all good. So let's do a refresh on Trig. Here's some tips, and these are general tips that can help with basically all our problem solving. Okay. Number one, and it's what a phrase we use all the times here at Breakthrough Math, and that's think in ink. And guys, I could not agree with it more, right? Don't spend ages looking at the question, wondering how you're going to get all the way through it. The best thing you can do when you see a question is to immediately start writing stuff down. So start thinking, what does this question ask me? Write that down. What formulas are associated with that question? Maybe write that down and think through your process using your pen. Because otherwise, you might be in an exam, you might be stressed, you might be nervous, your thoughts can start going flying everywhere, and you're not focusing on the question. Think in ink, right? As well as that, it's great exam technique because when the marker's going along, they'll see your thought process, they'll know what's going on, and then be able to say, this is where this person was going in this question. So even if you get the question wrong, you'll be able to recoup some of those method marks and stuff. Second tip is that the later questions generally harder and worth less marks. Skip them if they're taking way too much time, right? Now that's only sort of worst case scenario, guys. I want you guys all to be able to do all these questions in your leaving cert, okay? That's our aim. Our aim is always 100%, right? But generally, if it's hard and it's taking way too much time, skip them and maybe come back at the end if you've got spare time there. And the third tip, if you can't get a question, but you need a chance to use a yes question, this one's maybe a bit sneaky, but you can just write down a random answer and use it correctly for full marks. So if you need an angle to calculate the next part of your question, but you can't get what that angle is, you can write in a number and then you'll get your method marks, okay? But again, guys, this is last resort stuff. You're all going to be getting these answers and I have full confidence you'll be able to get them, okay? So let's start going through some trigonometry, okay? I want you to view your log tables as being one of the most critical things which you can learn how to use the maths for your leaving cert, okay? And page 16 for your log tables is crucial for this section. A big tip I want to give you guys as well is use your log tables when you're doing practice questions. A lot of people will not use the log tables, will go into the exam, and will suddenly be very flustered, flicking through log tables, trying to find the right pages, trying to go back and forth from the exam and your log tables. Get familiar with using them when you're doing your practice questions because you have all these formulas. When you have these formulas, there's no point you trying to memorize them when you've got them there. Prioritize your brain for solving problems, right? Not filling up with maybe formulas you don't need if they're in your log tables. And you'll get to know which ones you need and don't need and stuff as well. Let's do a recap from our junior start, okay? So bottom half, page 16 here, we've got our diagram of a triangle, and in it we're introduced to three things: sine, cosine, tan. Now, sine, cosine, tan are often very difficult for people to understand at the start, and that's mainly because they think, I've never heard of these terms before. These are ancient Greek words. What are they even doing on my page, right? But the only way I want you to think about sine, cosine, tan are as functions or tools which describe the ratios in a triangle. Okay? Think in ink, but also think in English sometimes is way handier as well. Let's think about sine A. What does that actually mean? That means that sine A is equal to our side A divided by our side E, our side C. So our opposite divided by our hypotenuse. All that does is describe the ratio of an angle to two sides, and that's it. And all three of them describe different ratios, and from them we can start to understand how a triangle works and how to answer some questions. Important to note, there's a right angle triangle as well. And our other most famous theorem, which everyone loves so much, I know I do, it's called Pythagoras Theorem. And Pythagoras was an ancient Greek mathematician, very, very famous at the time. He had a big school and everything. He rivaled Aristotle, one of the really foremost mathematicians and philosophers of his time. And he came up with this formula: c squared equals a squared plus b squared, which is hypotenuse squared is equal to the sum of the adjacent plus the opposite squared. Okay? So let's go through that. We use this whenever we have two sides of right angle triangle and we're trying to find the third side. This is the kind of stuff that thinking in ink is really handy for. So you can turn around and say, I've got the hypotenuse, I've got the opposite, I'm looking to find the adjacent. How do we do that? Pythagoras. When you have two sides of right angle triangle and you're trying to find the third side, we use Pythagoras' theorem. Now, the important thing, I'm going to point out a few mistakes people always make. We're going through this question here. Let's say I've got a squared plus b squared equals c squared. And what I'm looking to find out here is c squared, right? This is the most common example we'll get. We'll be asked to find out what is the hypotenuse. Normally, people get these first two steps correct, right? They'll substitute incorrectly. That's all good. They'll write 8 squared plus 7 squared equals c squared. Perfect. Then they'll write 64 plus 49 squared. 64 plus 49 equals c squared. Again, correct. We've squared out our terms. Finally, to add them together correctly, because remember, we've got our calculator here. But so many people will leave it at this. They'll completely forget that you need to square root this at the end. Right? That is, if I could tell you one thing that is the most common mistake people make about Pythagoras theorem is that they don't square root it at the end. Okay? So just make sure you do that. Think about like a big red flashing light in your head going, square it at the end, square it at the end, square it at the end. Okay? Really, really important that we remember to do that, okay? What about sine, cosine, tan? So let's refresh them. We use sine, cosine, tan whenever we have either an angle and we're looking for the length of side, or we have sides and we're looking for an angle. So what's the difference between sine, cosine, tan and Pythagoras theorem? Well, Pythagoras theorem only applies when you have two sides and we're looking for the third one. Whereas with sine, cosine, tan, we use them with a combination of sides and angles to be able to find out basically everything about our triangle. Okay? And let's remember the difference between sine, cosine, tan and our wee sort of mnemonic or rhyme. We've got SOHCAHTOA. And I know all your teachers and stuff probably have different mnemonics to that. I find that quite easy to remember, to be honest. SOHCAHTOA. Right? Sound like volcanoes or something. An easiest way to remember that is just opposite over hypotenuse is sine, adjacent over hypotenuse is cosine, and opposite over adjacent is tangent. And those are sort of full words for that, okay? All right. Now, I want you to give this one a go, guys, okay? I want you to use the diagram on the right to calculate the value for x. And I want you to give your value in surd form, okay? So have a think about what formula are we using for this, right? Have a think. What have we got? What information have we got? I want you to think and think. Okay, I want you to think and think. So take about 2 minutes to do that, guys. Can I move it over a little? Hopefully that's okay, guys. Hope everyone can see that. I'm just going through some of the questions now I might have missed. Hope that's okay now, Laura. Yeah, that's a really good thing. Someone's just pointed out, guys, it's always important to realize when we've got our right angle triangles, okay? So this is a right angle triangle, so we can use our formulas for that. Brilliant, I'm getting some answers in now, guys. Just text me your answer when you get it done, okay? Yeah, and as TJ said there, guys, just direct your answers to me. So, guys, remember we're looking for it in surd form. Yeah, really good. Some people are answering me in decimals and stuff. That's a wee bit off. Just make sure it's in surd form. Okay. So let's see again. Some answers in now, guys. I'll give you about a minute more or two. So some people are just answering to explain what surd form is, guys, right? Let's say I had a term like let me think. If I was asked, I might have something like square root 27. Okay? That isn't in surd form. Okay? Or the surd form we're looking for would be to simplify that down. So how do I simplify surds? I want to think about two numbers. Think about a square number times another number. And if that's equal to this term we have here under our square root, then we expand them into that. This example is going to make that a wee bit clearer. So let me think about some of the factors that go into 27. 27 is 9 times 3. We all know that, right? And we can write square roots like this. Square root 9, square root 3. But we all know what square root 9 is. Well, square root 9 is just 3. So we can write 3 square root 3. That's an example of the surd form. Your answer should be in a very similar form to that, okay? Brilliant. I'm getting some really, really good answers in. Really, really good, guys. Some people are asking that they don't know how to type it out in computer. Just type it out in English. So you might have, 5 square root, whatever. You can just type it out. Molly, hope that answers your question about what surd form means. So guys, I'm going to go through this answer as an example, okay? Loads of people have got it right, so well done everyone out. And if you didn't, that's okay as well. Don't worry, right? So let's have a think. We only use the diagram on the right to calculate the value for x. Now, if I was thinking the link, I'm thinking I have two sides. So I'm writing this down. All right, this is me. I'm going through my test right, and I've got two sides, and I want another side. Right? Now, if you remember, our good old pal Pythagoras developed a lovely handy formula for us to do this with. So that's what we're going to do. I want this side x here. So I'm going to write this out. This is also the hypotenuse. So I know my formula is x squared equals 3 squared plus 3 squared. Right? So that gives me x equals 9 plus 9, which gives me x squared equals 18. Now, so many people will leave it here. This isn't what our answer is. Our answer goes a bit further. We need to square root it. I'm just going to rub out this so far. When we square root 18, we get x equals square root 18. Remember that I've got x now, not x squared. So I'm just going to erase that. But how do I split 18 into surd form? A lot of people got this right. Well, 18 can be written as square root 9, square root 2. And we all know square root 9 is just 3. So I get 3 square root 2. Okay? That sound good, guys? Can you give me a thumbs up if you think you got that one and you're happy enough? Great. Seeing a lot of thumbs ups. Really good, guys. Sounds good. Thank you very much. Right? A lot of people got that one right. So well done for everyone. And remember, guys, think about your thinking in ink there. Right? Think about that exam technique we're using. Once you just give this one a go now, this one's using trigonometry. So this one says use trigonometry to work out the value of x in our diagram below and give your answer correct to two decimal places. Now I'm going to write up our little mnemonic to help people remember, but I'm not going to do it for the next question. Remember, we have SOHCAHTOA, right? SOHCAHTOA, right? And we've got to suggest the maximum time is 10 minutes, but that it won't take you that long. Someone's asked how I got 18 from 3 times 3. Well, it wasn't 3 times 3. It was 3 squared plus 3 squared, okay? And that is 9 plus 9, which gave me 18. And guys, just direct all your questions to me, not TJ, okay? Really good. I'll give you about 2 minutes to do that, guys. Just try your best there. And when you get your answer, please send it on to me, okay? And remember, we're asked for to two decimal places. But yes, I did use the factors of 18. So when we look at the factors of 18, what we're looking for is one factor, which is a square number, and one factor, which isn't a square number. Okay? Because then when you write the square root of them, we can reduce that number. So for example, when we have square root 9, square root 2, we reduce that to 3, 3 root 2. Okay? Okay, guys. Keep working away at that, right? I know that one's maybe more difficult than the last one. So someone's asked, how do you determine which formula to use? So I'm going to show you that, guys, right? The letters beside each A, C, and T here indicate which sides can we use these formulas with. So my angle's here, and the way I want you to think about which side is which is imagine standing in this corner. Imagine I have Tom here, right? What side would you say is opposite Tom? Well, this side. It's the furthest from me. I can't put my hands on it. That's my opposite side. And which side is the adjacent? Well, that's the one beside Tom. So let's look which trigonometric formula uses the opposite and the adjacent. Well, it's tan. Okay? So that's a good way to remember what side is sort of the opposite and adjacent. You'll not be able to touch the opposite. You will be able to touch the hypotenuse, and you will be able to touch the adjacent, okay? Okay, just get my answer ready now as well. Really good work, guys. So just shoot me a text with your answer there. Still waiting on a few. Okay, I'll give you a minute or two more. Not much longer than that, okay? Just do your best. Really good, getting some more answers in now. Okay. To get a few answers in, guys, always make sure your calculator's the right setting and stuff as well, okay? Okay, getting a lot of answers here. That's okay. Yeah, a lot of people text me. Just make 100% sure here. So guys, what we end up getting is this, right? I'll go through this as an example. So here's our angle here, right? We're looking to find the adjacent from the opposite. So we know that tan times my angle is equal to the opposite over the adjacent, right? That means that x times tan of 20 is going to be equal to 6, which tells me that x equals 6 divided by tan of 20. Now, what I want to do is I want to type that into their calculator now for me, okay? X equals 6 divided by tan 20. And then I want you to text me that answer just to make sure everyone's calculators are working okay, all right? So I want you just to text me your answer when you get that. Okay, good. Gonna reveal the answer now in just about 2 seconds. Yeah, really good. So a lot of people got that. Some people, there's two answers you can get for this, right? And one of them tells me that your calculator is wrong setting. If you got 2.68, your answer, your calculator is currently in radians. So you need to go through and make sure your calculator is set to the degrees setting, okay? And it'll be stuff online where you can figure out how to do that with whatever calculator you're using, okay? But the correct answer, guys, was 16.48. So congratulations if you got that. Really well done. Okay, 16.48 was what we got for that. Really good work. Okay, so I'll write that up just so everyone can see it. 16.48. And if you didn't get 16.48, but you entered it incorrectly, and you got something, I think it was 2.68, your calculator is in radians, right? And radians is just another measurement we use instead of degrees, but we always use degrees and leaving cert. So you want to change that, okay? Change that we set, all right? Great work, guys, okay? Really, really good. Move on to our next one. So this one is one of the ones which they throw in to make it seem a bit more complicated, but it's really not. Okay, so we're asked a candle is made from solid cone of wax that has radius 4 and slant height square root 52. And the question asks us to find height h of the cone. Now you might look at this and think, God, this is really difficult. There's a cone involved, it's 3D. But I'm here to tell you it's not actually 3D at all, guys. Although the cone itself is 3D shape, what we're looking at here is a triangle within the cone. So when we think in ink again, I can draw out the triangle I'm looking for. Here I've got square root 52. Here I've got 4. And I'm looking for h. I'm not going to tell you what formula it is. There may or may not be a very unsubtle hint on the screen as to what formula it is. So you might be able to use that. So someone's asked, how do I know which figure to round to? So it'll specify which figure to round to. And if it doesn't specify, guys, I would always just go for 2. Okay? So if it doesn't specify, go for 2 decimal places. Got some answers in already. Really good. Take your time with these though, guys, okay? All right, guys. And just a reminder that at the end, you're going to be getting a wee test again, just like you did yesterday. Okay, I'm getting a lot of answers in. Keep going with these, guys. Take your time. Don't worry. Okay. Okay, someone's asked, how do I round to decimal places? Okay, so I can really, really quickly explain that, guys, right? So imagine if I get an answer in my calculator. Oh, imagine if I get an answer in my calculator, and what it reads is 5.8897, right? And I'll be asked to round it to 2 decimal places. So what I do is I go 2 decimal places into my number. So I'll be here. I look to the number to the right of 8. And if this number here, so if this number is greater, equal to, or greater than 5, then I add 1 to 8, and that's where I round it. So for example, if I had this one, I can see 9 is obviously greater than 5. So this number then becomes 5.89. Okay? If it's less than, you just leave it. So it will be left as 5.88 if it was like 5.81 or something, okay? That's how we round. Good question. Okay, getting a load of answers in, guys. Okay, remember we're looking for the height. So we're looking for h, okay? Someone's asked how we know on a date. So I'm going to reveal these, guys. This is a Pythagoras Theorem, okay? It's written up there. And someone's asked, how do I know that on the date? Again, if I'm going through this question, I'm thinking of ink. I'm looking a third side, and I've got 2. So what does that tell me, guys? One of our only formulas we use in that, when we've got a right angle triangle, Pythagoras. So it's definitely Pythagoras. Slight tweaking of the last question is that our formula is now going to read square root 52 squared is equal to 8 squared plus 4 squared. Because remember, it's always the hypotenuse is equal to the sum of the other two sides squared. So give that one a go, guys, now, okay? If you've maybe done that one wrong, you can give this formula a go and try and figure out what h is, okay? So that's going to involve bringing your 4 over. All right? That's going to involve bringing your 4 over. Okay, a lot of answers coming in now. That's good. Some people changing their answers and stuff. Great. Okay. Good. So I'm going to show you how we do this one now, guys. So what we get is 8 squared is then equal to square root of 52 squared minus 4 squared. So what is that equal to? Well, I get h equals 52. 8 squared, sorry, equals 52 minus 16. I've squared out my 4, I've squared out, obviously square root of 52 squared is just 52. And then 52 minus 16, guys. 52 minus 16 is 36. So I get 8 squared equals 36. And the square root of 36, h is just 6. Okay? So that's what I end up getting. Give us a thumbs up if people understand how I got that. So I took it away because I brought my 4 across. So when I bring my 4 across the equal sign, it becomes a minus, okay? So that's why I brought it across. So if someone's asked when you typed in the square root, it said to be an error, you're going to get that if it's a minus under the square root. I left the 52 the same because square root of 52 squared is just 52. Okay, so the square root of 2 squared is just 2, square root of 4 squared is just 4. Okay, so if I've got a square root, I'm squaring it, it just becomes the number under the square root. Some people saying they use trigonometry instead of Pythagoras. It's a really common mistake, guys. That's why it's so good when we think and I can think 2 sides, need a third one. What was your uncle Pythagoras? Okay. So let's move on to the next few question. For this one, guys, I'm going to be called on a few people to maybe help me for this next few section, okay? This next bit can be a wee bit confusing. We've got what's called sine inverse, cos inverse, and tan inverse. And we're thinking, what do these buttons mean? Or what do they do? Well, guys, if we're looking to find an angle, here's where we use sine inverse, cos inverse, tan inverse. And here's how we use it. Suppose that I know two sides of a triangle and I want to find the angle. So here's our brilliant example here. Here we have 25 and we have 16, and we're looking to find this angle x. Well, correctly, we use the cos formula because I've got the hypotenuse and I've got the adjacent. So think k, think cos, right? And I know that cos x is equal to 16 over 25. And I want to find out what x is. Well, the way I get x on its own is I take inverse cos of 16 over 25. So you should have that button on your calculator. Sometimes you have to put your calculator to a new sort of mode. It'll say inverse mode or something sometimes. But we should have that button on our calculator. It says cos minus 1, 16 over 25. And that gives us 50 over 2. Okay? So when we're bringing our cos across and we're getting x on its own, we make it an inverse. Okay? The way I want you to remember is that we use the inverse when we're looking for angles. So think inverse, think angle. Don't fear sine, inverse, cos inverse, tan inverse. They're just different buttons on the calculator, okay? They're no different to your normal trigonometric identities. Right? So let's go through this Pythagoras question, guys, right? I'm going to be calling people to give me a hand. This photograph shows a house. This is a bit of a problem-solving one. Part of the roof of the house is going to be shown on the diagram below. And AB is perpendicular to DC. So that tells us that there's a right angle there, okay? And AB is the line from A to B, and DC is the line from D to C, okay? The length AD is 11.8, and length DB is just 2. So you can see that displayed in our diagram here. We know that the angle CAD is 20. We can see that here. And the angle DBC is X. We're asked to use trigonometry to work out the value of X. Right, it's a bit of a tough one there. First thing you need to do is find out the value of H. That's where we start. Start with the value of H. Okay? Now, how can you figure that out? Well, you've got an angle, you've got a side, and you're looking to find out H. So let's start off with that. First thing I want you to do is find out H for me, okay? So someone's asked what is an inverse and what does it do specifically? Specifically, when we're looking at inverse, is when we're looking at an angle. So if you're trying to find out an angle using trigonometry, you have to use your inverse, okay? So guys, I want you to figure out what H is, okay? So once you figure out what H is, I want you to text me your answer, okay? So I'll give you a hand. Here we've got an angle. We've got a side, and we're going to find out H. H, in this instance, is our opposite. And we've got our adjacent. So we're going to be using sine. And we know sine of 20 is equal to H over 11.8. Okay? Wow, some people went on ahead and calculated what X is. I just want you to start off with H, guys. Really good work. Okay. So let's see, a few people have a few different answers. Oh, sorry, I've got that one wrong. Sorry. You don't use sine for this question, guys. That's my mistake. Sorry. Whoops. We use tan for this one. That's absolutely my mistake, guys. Whoops. We use tan. Oh, big error there. Because this is our opposite and this is our adjacent, so we use tan. Okay? So it's tan 20 equals H over 11.8. Sorry, that's my fault, guys. Okay. So a few people got that answer correctly. Okay, so I'm going to call on someone to give me a hand here. Let's see, I'm going to go for, I've got Dara Clerkin. Can you hear me okay, Dara? Oh, sorry, I'm going to unmute you now, Dara, 2 seconds. Let me see. Hi, Dar. Can you hear me okay?
Yeah, can you hear me?
Yeah, I can hear you perfectly. Dar, don't take me through how you got the answer to this question and what it was.
I did the tan 20 in my calculator and I multiplied the results that I got from that by 11.8 to get H.
Absolutely super. And what was your final result, Dar?
4.294848,764.
Super. Really, really good. That's exactly what we're looking for, guys. Okay. So I'm gonna write that down in a sort of summarized form. Just I'm gonna write that down in 2,000 places. Okay, just to avoid writing it all over the screen. So that's 4.29 is the way we can write that. Okay. Well done, Dar. Really, really good work.
Thank you.
Okay. Well done, mate. So let's see. So now that we've got H, I want you to now figure out what X is. Okay? So we know the H is 4.29. 4.29. And we're looking to find out what X is. So we've now got two sides and we're looking to find out an angle. So we're using our inverse trigonometry formulas. And again, I'm going to help you to figure this one out. In this case, we've got the adjacent on the opposite again. So we're going to be using tan. And we know that tan of X is equal to the opposite over the adjacent. So 4.29 over 2. And I want you to figure out what X is. And you're going to have to use your inverse tan formula, okay? All right, so you're going to use your inverse tan. All right, and again, I'm going to be calling on someone to give me a hand with this one, all right? Okay. So text me your answer when you get that one. Oh, guys, I'm seeing some brilliant answers in. Really, really good. I think everyone's really understanding this. Perfect work, guys. Really, really good. Absolutely delighted to see all this. Perfect. This is a long question, guys. This is more of a problem solving one. This is one of the more difficult ones we get. So well done to everyone get that. Someone else, how do I lay out the question after that? So you just write out your answers. So you'd say h equals this and x equals that. Okay? That makes sense. All right. And again, I'm going to be calling on someone to help explain this one for me. Okay, so just another minute or so, guys, all right? Seeing some brilliant correct answers. Okay, I would stress some people probably aren't using the inverse tan. Okay, some people may be forgetting to do that, all right? Okay. So let's see. So really, really good work, guys. I'm going to call on someone now to help me with this one. So let's see. Morgan Watt, can you hear me okay?
Yeah,
Super, Morgan. How you getting on?
I'm good. I'm actually Lucy.
Oh,
My
sorry.
dad's account, you're fine.
That's no problem. I'll read any.
Um,
Lucy,
how
Lucy,
did I
what
get
is
it?
it? Yeah.
So I divided 4.2948, which is h by 2, and then I got 2.1474. I got the second function of that, which is 65.0295, and then I got 65 degrees because it's a whole number.
You're absolutely right. I'm afraid I was too slow for you there. Could you just type
Sorry.
in what you put in the inverse tan? Like what was in your sort of bracket there?
Inverse of tan is 2.1474.
1,474. So that's absolutely correct. And then your answer came out to be 65 degrees.
Yeah, 65, yeah.
Absolutely brilliant. Well done, Lucy, not Morgan. Apologies for that, but thanks for answering me
You're
anyway.
fine, thank you.
That's all. Really, really good work. So, guys, that's how we do inverse tan. And let's take a step back and think what we've done so far today as the sun starts to blind me slightly. I'll tilt my camera down a wee bit. But yeah, what have we done so far today? We've went through Pythagoras. We've done that really exceptionally well. Done some problem solve ones with it. We went through how do I find sides using trigonometry, and now we went through how we find angles. So we're now well equipped to answer a lot of questions. There's one more wee section, guys, which is trigonometric rules. These seem really complicated, but they're really not too bad. And you're given all of them, right? So they're not too bad at all. There's three rules I want you to think about. One is called the cosine rule. The important thing with these rules is to remember the situations in which they apply. Now, what I mean by that is, what information do I have? What information do I need in order to use these rules. So let's have a look at the cosine rule. Sorry, man, lighting's gone absolutely crazy here. I feel like I'm in the dark. Anyway, for the cosine rule, we're looking to find the third side of a triangle when we have the other two and the angle in between them. So the third side of a triangle when we have the other two and the angle in between them. So for example, guys, we might have a triangle that looks like this, right? We might have A, B, so capital A, and we're looking to find out C, or vice versa, okay? So two sides, the angle in between them, and we're looking to find another one, okay? Or we might use it to find the angle when we're given three sides of a triangle, okay? The sine rule is when we need one side and an angle opposite, is you need one side and angle opposite, as well as one other angle or side for that one, all right? And the area of a triangle, well, that's the easy way to do that is we have the product of any two sides multiplied by the sine of the angle in between them. So again, if I have a triangle that looks like this, let's have A here, B here, C here. To find the area of that triangle, I multiply A by B, half them, and times them by sine C. Okay, so let's have a go at some questions like that, all right? These seem very difficult, guys, but they're really not, okay? So this question asks us, find the distance x in the diagram below, okay? And I want you to give your answer correct to two decimal places, okay? And here's a hint, guys, this is sine rule. I'm going to write up the sine rule for you for this one, okay? Well, let's have a look, actually. Well, let's go through this one together and see what rule we're going to be using. So we have two angles, one side, and we're looking to find another side, okay? And now look at this. So for the sine rule, we need one side. We've got one side. We need the angle opposite side. We do have that, right? As well as one other angle or side. We've got this angle here, right? Or the other way we can think about this, guys, we can look at the cosine rule as well. Cosine rule is when we're looking to find the third side of a triangle, or when we want to find the angle when given three sides of the triangle. So there's a number of ways we can do this, guys, right? Remember as well that we can easily find out what this opposite angle is. And then we can use the sine rule, okay? That's the way I would go about this. But I'll give you 2 or 3 minutes to have a think about it, right? I'll leave the sine rule up there for you, okay? Right, I'll be doing this in a few minutes, guys. This one is particularly difficult, right? It's taken from an exam. But just try your best to get, and we're applying the sine rule this time. So think about how do I get the angle opposite x, and then how do I plug it into our sine rule to then figure out what x is, okay? Someone say, can I zoom in a bit, please? I'm trying to keep that sine rule on the screen, but I can just write it up myself, I suppose. So yeah, I'll zoom in on this. And remember, our sine rule is A, where A is a side. And capital A is the side opposite A. B over sine B. Okay? And remember, how do we think we could figure out what this side is? Or what this angle is? Brilliant. Good little answers in already. Really good. So guys, the rule of thumb is capital letters are always angles. Someone asked me earlier about a question I didn't quite see, and that was on our previous one. So Abby, you asked about the losing attempt marks. You wouldn't lose any attempt marks to that, okay? Someone asked in the previous question where the 2.1474 come from. That came from dividing our kh by 2. Okay, getting a range of answers in now, guys. Really good. Okay. All right, so this one seems maybe complicated to start, but once you fill in your formula, you'll see it becomes a wee bit clearer. All right. And remember, guys, your calculator can do a lot of the heavy lifting for this one, okay? So your calculator can do a lot of heavy lifting for this, all right? Mhm. See, and again, I'm going to be asking someone to help me out with this one, okay? And I really appreciate their help. We got some really good right answers, yeah. Okay, got a range of answers. A lot of people not maybe too sure about this one, guys. So I might go through an example. I've got some right answers as well, so that's really good. Oh, some people have set the formula correctly, but don't know what to do after that. Okay, really good. And a lot of people have forgotten how to calculate the angle. That's okay. I tell you what, I'm gonna ask someone to help me go through this one. Okay, someone knows knows the angle but doesn't know how to do the rest. That's okay. I'm gonna go to let's see, Eve Swanton. Okay, gonna ask you to unmute here 2 seconds. Let's see, Eve Swanton. Let's see. Hey,
Sorry,
Eve, how are you
sorry.
getting on?
Hi. Is this working? Sorry,
Yeah,
it just wouldn't
I
let
can hear you perfectly.
it
Eve, what
wouldn't
about?
let me unmute for a second.
Oh, sorry.
Yeah. So you kind of
Here, don't
I'm
worry.
terrible at explaining things, but 10 centimeters over sine 63 degrees equals x over sine 52.
10 sine 63 equals x sine 52. Absolutely correct, yeah. And where do you go from here, Eve? A lot of people filled it in here and didn't know where to go.
So that means you have to calculate 10 over sine 63, and that's also equal to x over sine 52.
Yeah.
And what I did is I multiplied both of them by sine 52, and that
Okay.
gave me 8.84, so that should be x.
Okay, yeah, that's absolutely one way you could do it. The other way I did it, guys, is that you could cross multiply it, or Eve's way is actually probably quicker. So Eve, maybe you should be taking this lesson. Really, really good work. So yeah, you're absolutely right. What we end up doing is I got sine 52. Yep. So we can multiply both sides by sine 52. So we get sine 52 equals, or times 10 over sine 63 equals x. And Eve, what was your final answer?
8.84.
And that was absolutely correct. Well done, Eve. That's our final answer, okay?
Thank you.
Really, really good work. Okay, so 8.84 was our final answer, okay? For that one, right? And Eve has very well explained how we got that answer, okay? Really, really good work. Okay, so let's move on to the next one, guys. Where do we get the 52 from? Yeah, really good question. Where we got the 52 from, we added up 63 and 65, which gives 128. And when we took that away from 180, because all angles add up to 180, this turned out to be 52. So we add these two together, and because it's 128, and we're going to take that away from 180, and that's going to give us 52. The cross multiply way, someone's just asked how to do it. Well, how you do the cross multiply way, guys, really simply. You just cross multiply two fractions together. So I'll go through this really, really quickly. So imagine if I had x over sine 52, and that was equal to 10 over sine 63. If I was cross multiplying this, what I would do is multiply sine 52 by 10, get sine 52, and I would set that equal to x times sine 63. So then I would actually end up dividing this side by sine 63, and they give you the same answer. Okay? Eve's is actually a lot more quick, so a lot quicker. So I'd recommend that one, to be honest. My way is a bit old-fashioned, maybe. Okay, but really, really work, guys. So let's move on to the next one. Conscious we've got a wee bit more to get through. So let's go through this next one here. This question asks, find the distance y in the diagram below, not to scale, and says, give your answer correct 2,000 places. Guys, spoiler alert, this is the cosine rule, okay? So I'm going to write the cosine rule for you guys. So it's a squared equals b squared plus b squared. It's, let me see, I'll zoom in maybe a bit first. So it is a squared equals b squared plus c squared minus 2bc cos of a. This is a. Yeah, this is a. We're going to find out. This is b, and this is c. Okay. So have a go at that, guys. Again, calculator doing so much the heavy lifting here. Okay. All right, so your calculator's doing all the heavy lifting here, guys. The main thing you need to do is make sure you enter all your values in correctly, okay? I know it sounds silly, but that's a really big way people make mistakes in their tests. It's just entering in values incorrectly, okay? And those are marks we don't want to lose. Okay? We're sort of selling ourselves short there for losing sort of silly mistakes like that. So yeah, it definitely takes a wee while, guys, with the amount you have to enter in your calculator, but just do your best, okay? And I would recommend doing it in stages. So do your addition first, do your squaring first, write it down at each stage. So you're making sure you get all those method marks. Okay, really, really good work, guys. Okay. So just send your answer to me, guys. Still waiting on a few answers, but don't worry, I know this one takes a lot longer. Okay. And remember that square root at the end, guys. People always forget our square root at the end, okay? Let's see, I'm getting a few answers in now. Good. Oh, brilliant, guys. Getting a load of really good answers in. Absolutely perfect. Yeah, really good. Really, really good. We're looking around at the 2 decimal places, guys. So that means 2 decimal places in. So for example, if you had 7.777, that would round to 7.78, okay?